Students, network performance की बात करेंगे. Students, data transmission हमने cover की data transmission over a transmission medium and how the data behaves over a transmission medium. All of that is important. But what is even more critical is how good is our network? How well is our network performing? So network performance is another important theoretical measure that we need to have for a successful and efficient data communication system. Students, there are three different characteristics of network performance. In essence, when we talk about the finding out how good our network is performing, we need to look at these three characteristics, and we will go through these in further detail in the rest of the course. But for now, just to introduce you, the first one is bandwidth, the second one is throughput, and the third one is latency or the delay. Students, सबसे पहले bandwidth की बात करेंगे. Students, bandwidth is an important characteristic of a network performance. Bandwidth, as we have gone through it in the previous discussions, can be used in two different contexts. The first one is the bandwidth in Hertz, and the second one is the bandwidth in bits per second. As you can see, the bandwidth in Hertz is nothing but it is the range of frequencies in a composite signal. It's the range of frequencies a channel can pass. तो हमने bandwidth का जिक्र, जो पहला context था जिसमें हमने bandwidth का जिक्र किया था, that was in the context of the bandwidth in Hertz or cycles per second, and we spoke about the range of frequencies that can actually pass through a channel. हम लोगों ने ये discussion की थी कि the bandwidth for a subscriber telephone line is 4 kilohertz. That is nothing but the concept of how much a telephone line as a channel can pass. Students, the second definition of bandwidth that we went through was the bandwidth in bits per second. Students, in this particular case, it is the number of bits that a channel, a link, or a network can transmit. Students, हम लोग different types of LAN पढ़ेंगे, but for an example, the maximum data rate that an Ethernet network or a fast Ethernet network that it can pass is 100 megabits per second. What this essentially means is that this network, this fast Ethernet network, can actually send 100 megabits per second. Students, there is a relationship between these two concepts. An increase in bandwidth in Hertz means that we have an increase in the bandwidth in bits per second. Of course, this relationship depends on what type of transmission are we talking about, but in general, the increase in bandwidth in Hertz means increase in bandwidth in bits per second. अब students, second characteristic की बात करेंगे, second characteristic of the network performance, and that is throughput. Students, throughput is nothing but a measure of how fast can we send the data over a channel. How fast can we send the data over a transmission medium? Now, students, bandwidth is not the same as throughput. From the definition, it may look like that the bandwidth and the throughput, they are one and the same thing. They are not. Students, what's the difference? Bandwidth of a link can be B bits per second, as you can see on the slide. But we can only send T, which represents throughput. We can only send T bits per second through this link with T or the throughput always less than the bandwidth or the B. So the theoretical maximum bandwidth can be anything. But throughput is how much data can we actually send on that link. Doesn't matter what the bandwidth is. Students, network with bandwidth of 10 megabits per second can pass an average of 12,000 frames per minute, and each frame carrying an average of 10,000 bits. And we have been asked to find the throughput in this particular case. So our throughput is going to be equal to 12,000 multiplied by the number of bits per frame, which is 10,000. And this has to be in seconds. So we come out with 2 megabits per second. Students, गौर कीजिएगा, हमारी throughput जो है, that is 2 megabits per second, given how many frames can pass per minute and the number of bits, whereas our bandwidth possible was 10 megabits per second. T is always lesser than B.